Alright, welcome back. This next section is on instrumentation. At a company we are familiar with, there was this massive application that was used by several different newspapers. A giant monolithic web application that had no runtime monitoring. The ops team was doing a great job keeping an eye on system resources, such as memory and CPU usage. But there was nothing checking how many API calls per second were going to the third-party video vendor and how expensive these calls were. One could argue that that type of measurement is achievable with logging, and that wouldn't be wrong. But again, this is a massive monolithic application with absurd amounts of logging already. Okay, I gotta take a quick break. I'll be back soon. Sorry, it's only been a minute in. Okay. The question here was how to introduce robust metrics with easy visualization and querying that wouldn't take 3 days of implementation training for developers and make it as easy as adding a logging statement in the code. Instrumentation of any technology at runtime has to be as close to the previous statement as possible. Any solution that drifts from that premise will have trouble being successful. If it is hard to query and visualize, then few people will care or pay attention. If it is hard to implement and maintain, then it might get dropped, which is what we saw happen earlier on in this book. If it is cumbersome for developers to add at runtime, then it doesn't matter if all the infrastructure and services are ready to receive metrics. Nothing will get shipped over, or at least nothing meaningful. The Python-statsd library is an excellent and tiny library that pushes metrics over to statsd, which can later be relayed to Graphite and can help you understand how metrics can be instrumented easily. Having a dedicated module in an application that wraps the library is useful because you will need to add customization that would become tedious if repeated everywhere. Tip: the Python client for statsd has a few packages available on PyPy. For the purposes of these examples, use the Python statsd package, install it in a virtual environment with pip install Python statsd. Failing to use the right client might cause import errors. Okay, so we're gonna create a new, if I can. I'm not sure what's going on here. Okay, well, we'll close it and then reopen it. Oops, I hit start instead of console. I meant to hit console. There we go. Okay, so I accidentally hit start, so I think it's got to restart. Let me just hit a restart. Reload. Okay, so it went to yellow, now it's red. So hopefully it goes back to green. I don't see it, so I'm gonna hit a start on it again. Okay, it's back to green. Okay, now I've got it. So I've got already the test project in here. So let's make a new folder. We're gonna call it instrumentation. I don't know if that's how you spell instrumentation, but it doesn't matter. Now we'll do a Python 3-mvnv vnv. Oops, looks like we've got a apt-get Python again. It didn't persist. Oh, it looks like I apt-got Python. Oh, I just did an update, so we gotta do an install as well. Okay. Okay, one of the simplest use cases is a counter. And the examples for Python statsd show something similar to this. Oh, so I'm going to do a pip install Ipython as well. Oh, I can't import it because I don't have a... Yeah, 3.5 is too... I have to use version 3.6 and above. Okay, well, you know what I can do? I can do this. Pip freeze, and then I can do so it says Python 7.10, so let's just do 7.0.0. There we go. So now I'm installing a different version of Ipython, one that will support version 3.5 of Python. Or not. I don't know what's happening again. Invalid syntax. Alright, well, can I just open regular Python? I can. Okay, so let's stop wasting time with that and just move on. This example assumes a statsd is running locally. Therefore, there is no need to create a connection. The defaults work great here, but the call to the counter class is passing a name. The name is passing is app. We can see that here. That will not work in a production environment. As described in naming conventions, it is crucial to have a, oops, and I don't know where I am now. I do still have a, I do still have a bookmark, so that'll be good. Yep. It is crucial to have a good scheme that helps identify environments and locations of the stats. But it would be very repetitive if you had to do this everywhere. In some graphite environments, a secret has to prefix the namespace on all metrics being sent as a means of authentication. This adds another layer that needs to be abstracted away so that it isn't needed when instrumenting metrics. Some parts of the namespace, such as the secret, have to be configurable, and others can be programmatically assigned. Assuming there is a way to optionally prefix the namespace with a function called get_prefix, this is how the counter would get wrapped to provide a smooth interaction in a separate module. For the examples to work, create a new module, name it metrics.py, and add the following. Okay, so we're going to create a new module named metrics.py. I'm going to add the following. By following the same example used in naming conventions for a small Python application that calls to the Amazon S3 API in a path such as web app API aws.py, the counter can get instantiated like this. Oh, so we got no module named getPrefix, so I don't know what they want me to do. Yeah, so assuming there is a way to optionally prefix the namespace with a function called getPrefix, this is how the counter would get wrapped and provide a smooth interaction in a separate module. So I don't know if there is a way to do that on my environment. So yeah, I might have to just skip that because I don't know if that assumption can be made on my environment. By using underscore underscore name underscore underscore, the counter object is created with the full Python namespace of the module that will appear on the receiving side as web.api.aws.counter. This works nicely, but it isn't flexible enough if we need more than one counter in loops that happen in different places. We must modify the wrapper so that a suffix is allowed. Okay, so I still can't do this because I don't have this import statement here. If the aws.py file contains two places that require a counter, say a read and a write function for S3, then we can easily suffix them. From metrics import counter, import BOTO. Okay. These two helpers now have unique counters from the same wrapper, and if configured in a production environment, the metrics appear in a namespace similar to this space. This level of granularity is helpful when trying to identify metrics per operation. Even if there are cases where granularity isn't needed, it is always better to have it and ignore it than to need it and not have it. Most metric dashboards allow customization for grouping metrics. The suffix is useful when added to function names or class methods that hardly represent what they are or what they do. So improving the naming by using something meaningful is another benefit to this added flexibility. Okay, so this is named helper for expensive operations on large files. Note, counters and other metric types such as gauges can be so easy to add that it might be tempting to include them in a loop, but for performance critical code blocks that run thousands of times per second, it might be impactful to add these types of instrumentation. Limiting the metrics that are being sent or sending them later are good options to consider. This section showed how to instrument metrics for a local statsd service. This instance will end up relaying its metric data to a configured backend like Graphite, but these simplistic examples aren't meant to be a statsd only solution. To the contrary, they demonstrate that adding helpers and utilities to wrap common usage is a must. And when easy instrumentation exists, developers will want to add it everywhere. The problem of having too much metric data is preferable to having no metrics at all. Alright, naming conventions. I'm only 19 minutes in. I think I just need another break, but I will come back and get started on naming conventions as soon as I can. So I'll just pause it and I'll be back. Alright, I'm back. I wasn't even 20 minutes away and I had to take a break. I took like a multi-hour break. So let's continue on with this. Okay. So the next section will be naming conventions. In most monitoring and metric services such as Graphite, Graphena, Prometheus, and even statsd, there is a notion of namespaces. Namespaces are very important, and it is worth thinking carefully on a convention that will allow easy identification of system components, while at the same time allow enough flexibility to accommodate for growth or even change. These namespaces are similar to how Python uses them. A dot separates each name, and each separated part represents a step in a hierarchy from left to right. The first item from the left is the parent, and every subsequent part is a child. For example, let's assume we have some API calls to AWS in a nimble Python application that serves images on a website. The Python module where we have the spot we want metrics is in a path like this. The natural namespace choice for this path could be web.api.aws, but what if we have more than one production app server? Once the metrics ship with one namespace, it's hard, almost impossible, to change to a different scheme. Let's improve the namespace to help identify production servers. Server name.web.api.aws. Much better, but can you see another issue? I can't. When shipping metrics, a trailing name is sent over. The other thing I don't understand is why it's hard or impossible to change to a different naming scheme. Like, it seems like, you know, if this is such a long-standing hard thing, like, this would have been worked on and solved by now. Like, I would be interested in, like, working on and solving the issue of changing name schemings being hard. Like, that sounds like an interesting problem, because I can imagine why it would be difficult. You know, to be honest, I really can't imagine why it would be difficult to date. Because, like, if it knows how to call something by one name, I don't understand why you can't just say, like, oh, now that name equals this, and when you call that name, change it to this, and then it just, like, goes through the code and kind of when it calls the name, it then changes the name. I guess you could get in, like, a situation where it calls back upon itself, and then now it has a different name it wasn't expecting, but I just don't understand. I wish they would have talked more about why it's difficult and impossible to change naming schemes. In the case of counters example, the name would be something like this. That is a problem because our little application does several calls to AWS, like S3. And we may want to talk to other AWS services in the future. It is easier to fix child naming than parent naming. So in this case, it just requires developers to match metrics as granularly as possible to what is measured. For example, if we had an S3 module inside the aws.py file, it would make sense to include it to distinguish it from other pieces. The child portion of that metric would look like aws.s3, and a counter metric would end up looking like aws.s3.counter. Having so many variables for namespaces can feel cumbersome, but most established metric services allow easy combinations, such as show me count average for all S3 calls last week, but only from production servers in the East Coast. Pretty powerful, huh? Yeah, that definitely is awesome. Like, and that's the kind of thing you'll hear a manager, you know, wanting. That's the kind of information that is really valuable to have. So yeah, that's awesome. There's another potential issue here. What do we do with production and staging environments? What if I'm developing and testing in a virtual machine somewhere? The server underscore name part might not help much here if everyone calls their development machine SRV1. If deploying to different regions, or even if there is a plan to scale beyond a single region or country, an extra addition to the namespace can make sense as well. There are numerous ways to expand on namespaces to better fit an environment, but something like this is a suitable prefix. Region dot, and then prod, staging, or dev, .server name. All right, logging. Oops, I'm going to keep that on there. Logging. It can be daunting to configure logging in Python correctly. The logging module is very performant and has several different outlets that can receive its output. Once you grasp its initial configuration, it isn't that complicated to add to it. We've been guilty of rewriting an alternative way of logging because of the dislike for configuring the logging module properly. This was a mistake because it almost never accounted for all the things that the standard library module does well. Multi-threaded environments, Unicode, and supporting multiple destinations other than stdout, just to name a few. Python's logging module is so big and can be made to accommodate so many different uses. Just like almost all software in this very distilled chapter, that not even a whole chapter would be sufficient to cover it all. This section will offer short examples for the simplest use cases and then move progressively toward more complex uses. Once a few scenarios are well understood, it isn't hard to keep expanding logging into other configurations. Even though it is complex and can take some time to fully comprehend, it is one of the crucial pillars of DevOps. You cannot be a successful DevOps person without it, without logging. Why is it hard? Python applications, like command line tools and one-shot types of tools, usually have a top-to-bottom design and are very procedural. I might probably.
Procedural.
Procedural. Yeah, I was saying it right. When you start learning development with something like Python or perhaps Bash, it is reasonable to get used to that flow. Even when moving to more object-oriented programming and using more classes and modules, there is still this sense of declaring what you need, instantiating objects to use them, and so on. Modules and objects aren't usually pre-configured at import time, and it is not common to see some imported module be configured globally for the whole project, even before being instantiated. There is this sense of somehow this is configured, and how is it possible if I haven't even called it yet? Logging is like that. Once configured at runtime, the module somehow persists this configuration regardless of where it is imported and used, and before creating loggers. This is all very convenient, but it is hard to get used to when almost nothing else works this way in the Python standard library. Alright, so the basic config of the logging module. The easiest way out of logging configuration misery is to simply use basic config. It is a straightforward way to get logging working with lots of defaults and about 3 lines worth of work. Okay, I'm going to highlight this. Alright, and then we'll run the example here. Oh, I do need a Python shell, I've got one. And it's the standard library, so I don't need to do a pip install. Okay, so we got our first logging message here. It's a critical logging message. It's logged to the user root, and it says this can't be that easy. With almost no need to understand anything about logging, messages appear and the module appears to be configured correctly. It is also good that it can support more customization and a few options that are well suited for small applications that don't need highly customized logging interfaces. The format of the log messages and seeing the verbosity are achieved with ease. They keep using the goddamn syntax. You know what? And those are not defined variables. I don't think this line is going to work. I'll try it anyway, though. Yeah, this is an old. We looked at the publishing information for this book, and it was written in like 2000. So it was first published in like 2019, and then it was updated in 2020. So I would say it's on the money as far as timeliness is concerned, but they're still using legacy, old school Python syntax. It's clear that the authors of this book learned how to do Python many years ago and just never updated their styles to use the new Python conventions, which is kind of annoying because I'm pretty sure I could do a free tutorial on the logging module and it would not be written like this. It would be written Okay, so warning is above info, should appear, but when we did a logger.debug, it didn't show up because our levels here were info, and it works like if you have a network engineering background, which this channel kind of is based on that a little bit, a lot bit actually. It works the same way as on network gear, so you get messages for the logging level you specify and for levels that are a higher level of severity, so that have I think the higher level of severity gets a higher number. I think that's standardized. I'm not exactly sure, but if I were to get like a critical message, I would still see that because it is a warning level higher than the info. But I don't get a debug message because it's a lower level of warning or of debug message, a lower level of debug message. This, or a low level of logging, it's a debug message, which is a type of a logging message. This example was configured to set the minimum level at info, which is why the debug message didn't emit anything. Formatting was passed into the basic config call to set the time, the name of the logging, more on that later in this section, the level name, and finally the message. That is plenty for most applications, and it is good to know that a simple entry into logging can do so much already. The problem with this type of configuration is that it will not be sufficient to take advantage of more complex scenarios. This configuration has a lot of defaults that might not be acceptable and will be cumbersome to change. If there is any possibility that the application will need something a bit more complicated, it is recommended to fully configure logging and go through the pain of understanding how to do that. Okay, so this is a long section. and it's only been a half an hour, but you know what? I think I'm gonna cut this video here. I just don't have the energy today. So I'll take the, you know, I put it in a half an hour, so I'll put that in the bank and come back to this later. So that's it. Fortunately, it's a shorter video than usual, but when I come back, we'll continue on with this book. The next section is deeper configuration of the logging module.